tree is a variation of tree data structure. No, not try, it's pronounced tree, but spelled weird. Just like N array tree data structure, a tree can have n children stemming from single parent. Usually all the nodes in a tree would store some character. Assuming we are only dealing with English words, here's how a simple example of tree may look like. You start with the node root, think of it as home base. From there, you branch out with each letter of your words. When you hit the end of a word, you plant a little flag saying, yo, this is legit word. So we got the conceptual background. Now let's try to code the representation of tree node. We can follow a similar idea of tree while ensuring it meets the requirement we discussed before. So it makes more sense now. Here's the final code. We can also represent it using simple E6 class. We've got the overall interface in place. Each tree would create its own root node null as part of initialization. Then we can implement the two methods: insert, search. In insert, we can split the words into letters and create node for each of these letters. Then we can start chaining each of these trees nodes to the root node to insert the word. Finally, we will mark the end of word property as true for last inserted node. In search, we can split the word into letters. Then we can start looking for each of these letters one by one, starting from the root. Then we are able to find all these letters sequentially. Then we can return true, else false. Now let's talk about the time and space complexity. In the worst case, each character of all inserted words can take up single node in a tree. So that would mean worst space complexity can be W multiply N, where W is average number of characters per word and N is the total number of words in the tree. While the insertion and searching time complexity will be big O of N. But how else you could search a word in a huge list of words? Probably using an array, time complexity will be big O of M, where M is the total number of words, which is pretty bad. How about using a map or an object in JavaScript? Well, that would decrease the time complexity to big O of 1, but how fast it would be to find the list of words having certain prefix? It would be big O of M. Tree not only brings down the time complexity to big O of N, the number of characters in word, but here you can effectively search for a list of words having prefix, which would be much more expensive task with any of these two approaches. This is it for the video. You can connect me on social media for more such fun talks together. Until next time, cuties.